So welcome to my lecture on measurement. This is how we're going to start things talking about measurement. And it starts off with a nice philosophical question. We don't do a journal here in online learning, but we could, right? You could think about, why is it that we need measurement, right? What is it beyond the need for, say, carpenters who are going to build a house or road workers who are going to lay a road? Why do we need a standard of measurement between things? And as scientists, the answer comes pretty quickly, right? We need measurement to be able to report our findings to one another, to be able to discuss our science across all societies and all walks of life. So what do we use as scientists as measurement? Well, we use something called the International System of Units, or the Système International, which is indeed French. It is abbreviated the SI system, and that was established by the General Conference of Weights and Measures back in 1960. There was a big meeting of engineers and scientists, and they got together and decided that this was going to be the standard measurement that engineers and scientists were going to use, and they based it off of an already existing system, which is the metric system, which gets its name from the meter, right, which is the foundational measurement unit that the French invented and used for many years before it was adopted by the Système International. It is a decimal system, so it does make sense, and it's been adopted mostly by a lot of other countries, but not by us Americans, and that's because we have our honorary right not to adopt that system. But even scientists in America use this system and report their findings in this system. And it is composed of mainly two different kinds of units here. There are the base units, which are something that you measure directly. And back in the day, base units actually were measured by comparing to a standard. Or it can be measured by a derived unit. A derived unit is derived from some base units or calculated based off of some standard that you know and can compare to. So they're either derived or calculated. Table 1 has most of the derived units, which are ones that we often find much more useful in our everyday life. And Table 2's got kind of the base units there. To start off with Table 2, start off with the base units. One that's really important in chemistry is mass. Mass is something we measure a lot in chemistry, and believe it or not, the base unit of mass according to the SI system is the kilogram. A lot of people think it's the gram, but it's not. It's actually the kilogram. So the base unit of mass is the kilogram. It is abbreviated kg, as a symbol of kg. The quantity of volume, which we often use in chemistry, is a derived unit, right? So it is derived from the meter. You take 3 meters and you put them into a cube, and you get a cubic meter, and that is the derived unit of volume. We actually don't use the cubic meter too much. We take that and derive it a little bit further, and we use the liter. And later on, we'll talk about where the liter comes from. But the actual SI unit is the cubic meter. We can take any of these units and we can make them larger or smaller depending on what we need to measure. And the way we do that is by adding prefixes to them. And so in the SI system, there are a whole list of prefixes. This is a nearly comprehensive list of the prefixes. There's a couple of more up top and a couple of, at least one more down at the bottom there. But most importantly here is this middle unit here, the multiple unit. For that, we're going to talk about scientific notation, and actually tomorrow that's something we're going to spend a long time on how to convert from one prefix to another. But a couple of prefixes that jump out. One that you may have heard in everyday life is hecto. A hecto prefix means that you have 100 of something, and the most often use of this in modern day language is, believe it or not, by farmers or real estate developers, which talk about hectares, which used to mean 100 acres. I'm not sure if it still does. I'm not a farmer, unfortunately. or fortunately, I don't know. And then there's a prefix that we can also use, say, if you want to make something smaller, and a common one that we've heard of is for 1/1000th. Instead of saying 1/1000th, we'll use the prefix milli. And so the prefix milli, which is abbreviated little m, is 1/1000th of something. And again, this table is going to be very, very important to us tomorrow. We love using this table because everything here is base 10. It's just multiplying or dividing by 10. Whereas if you think about the system that we use in America, it's called the English system, it's not actually a base of 10. And some of the bases that we use to convert things in the English system are incredibly weird, and that makes converting in the English system very, very hard. But we still use it in the United States. So what we're going to talk about a little bit today is how do you convert back and forth. It's not very easy. In fact, if you look here, the correct conversion for converting from 1 meter to inches, for example, 1.00 meters is equal to 39.37 inches. That's kind of weird. Why is this not a round number? To contrast that to converting from meters to kilometers, right? 1 meter is 1 kilometer is 1,000 meters. It's a nice round number to convert between those two. But if we want to convert from, say, kilometers to miles, well, 1.00 kilometers is 0.62 miles. It's a weird round way. Converting between these can be really difficult. And so I believe that should answer the first 9 questions. If you didn't get any of those, feel free to restart this video and try and pick them out of there.